All right, today we're going to take a really close look at Archer Aviation's Midnight aircraft. But, we're not going to get caught up in all the market hype. Instead, we're going to focus on the machine itself, the engineering, the design philosophy, and the huge challenge of actually getting this thing certified to fly.
And just to be super clear from the get-go, this explainer isn't about whether the company is going to be a huge commercial success or what its stock price is doing. Nope. We're putting on our engineering hats to really understand the hardware and the thinking behind it.
And that's because what's really revealing isn't the press releases, it's understanding the specific engineering problems Archer decided to tackle, and, maybe even more importantly, the ones they decided to avoid. Their entire game plan is baked right into the aircraft's design.
Okay, so let's start with their core business strategy, because honestly, it's the blueprint that dictates almost every single design decision they make down the line. So Archer has set themselves up not as a company that makes every nut and bolt, but as what's called a program integrator. What that means is they design the overall aircraft, and then they go out and source the major flight-proven systems from the biggest, most established names in aerospace.
Now, this slide is where it gets really interesting because you see the contrast in strategies. On one side, you've got Archer's model. They're partnering with giants like Honeywell and Safran for critical parts, and even using the automotive powerhouse Stellantis to actually manufacture the aircraft. This keeps their initial costs down, and, this is key, it helps de-risk the certification process by using components the FAA has seen before. On the flip side, you have a competitor like Joby, who is vertically integrated. They design pretty much everything themselves. Now that gives them total control to squeeze out every last drop of performance, but it costs a whole lot more money and presents a totally different set of challenges for certification.
And yeah, this quote from their CEO, Adam Goldstein, just says it all, right? It's not about building the flashiest, most high-tech thing imaginable from scratch. It's about finding the most direct, practical, and lowest risk path to getting a certified aircraft in the air and making money.
Okay, so with that strategy in mind, let's finally look at the actual machine it created.
This is an absolutely crucial design choice. There are no physical links, no shafts or gears, connecting all these propellers. Everything, and I mean everything, all the control, all the stability, is managed by software. It's a pure fly-by-wire system. This makes the mechanics way simpler. But the trade-off is that it puts an immense burden on making sure that software is unbelievably reliable.
So what's all this hardware supposed to do? Well, here are the targets. A top speed of 150 miles per hour, but it's really built for those short city hops, 20 to 50 miles. It can carry over 1,000 pounds, and the noise level is a huge deal. They're aiming for around 45 decibels at 2,000 feet, which is ridiculously quiet compared to a helicopter. So, we've seen the what of the aircraft. Now let's dig into the why. Because every single feature on the Midnight is a result of a very deliberate, very calculated engineering trade-off. And the guiding light for all these trade-offs is pretty simple. Design for certification. This means that getting the FAA's stamp of approval is often more important than chasing every last bit of performance. It's a really pragmatic way to approach it. So let's break these trade-offs down. First, they swapped mechanical complexity for software complexity. No hydraulics, no shafts. Second, they chose integration over pure optimization by using parts from trusted suppliers. Third, safety through redundancy. With 12 motors and 6 separate battery packs, there's no single point of failure that can bring the aircraft down. And finally, they're just being realistic about today's batteries. They designed the aircraft for short trips with fast recharges, not for cross-country flights. And all of this, every one of these decisions, leads directly to the single biggest mountain they and the whole industry have to climb, navigating the gauntlet of FAA certification. You see, the Midnight doesn't fit into the old boxes. It's not quite an airplane, and it's not quite a helicopter. So the FAA had to create a whole new category for it called Powered Lift Special Class. This means Archer has to meet a mix-and-match set of safety standards from different kinds of aircraft, which, as you can imagine, is a brand new and very complex path to follow.
And this timeline just shows you what a long, slow, methodical process this is. I mean, look at it. They applied for the main certificate way back in 2022. It took until mid-2023 just to get permission to start flight testing. Then the FAA didn't even finalize the specific safety rules until May of 2024, and now they're in the thick of the compliance phase, which is where they have to prove through tons and tons of testing that their aircraft actually meets every single one of those rules.
This whole thing breaks down into 4 key certifications. Type and production are about the aircraft itself and the factory that builds it. But check out Archer's strategy here. This is pretty clever.
They've already gotten their Part 135 and Part 145 certificates. Those are the licenses you need to run an airline and to maintain the planes. So, they're literally building the airline part of the business before the plane itself is even fully approved.
And these are the big dragons Archer has to slay for the FAA. They have to prove the batteries are safe from things like thermal runaway. They have to demonstrate that the fly-by-wire software is basically bulletproof. They have to figure out pilot training, prove they can hit those quiet noise targets, and finally, show that they can build hundreds of these aircraft exactly the same way, over and over again.
So when you step back and you put it all together, the business model, the engineering choices, the regulatory maze, it all really boils down to one huge fundamental question.
This, right here, is the whole ballgame. Archer is basically a giant test case. What they're trying to prove is whether this whole new way of doing things, a distributed electric aircraft that leans heavily on software and outside suppliers, can actually meet the incredibly high safety and reliability standards of traditional conventional aviation.
But look, we have to be realistic. Even if Archer gets that golden ticket from the FAA, it doesn't magically solve everything. The whole industry, including Archer, is still up against the hard physical limits of batteries, the incredible difficulty of certifying complex software, and the massive challenge of building an entirely new air taxi network from scratch.
Which really leaves us with this one last question to think about. If Archer succeeds, does that mean the entire eVTOL dream is validated and the skies are about to be unlocked for everyone? Or does it just prove that one very specific, very pragmatic approach was the right answer to this one monumental challenge? Honestly, the answer to that is going to define the next decade of aviation.